Okay, so we're going to solve number 8. We're going to simplify each of these. So we have 48 divided by the square root of 48 divided by the square root of 2. So the first rule for dividing radicals is to make one big radical. Then you simplify the fraction. Okay, so we're going to simplify that to 24 over 1. Okay, so we can just leave that as 24. So now we have the square root of 24, and we need to see if there are any perfect squares that go into 24. So I know that 4 is a perfect square, so 4 times 6 equals 24. 4 is the perfect square, and when we take something outside, when we break out of jail, only one makes it out, so that means we're left with 2 radical 6. Okay, so we put the radical sign back, and that is our answer for A. Okay, now let's try our answer for B. So for B, we have 2 times the square root of 72x cubed divided by 3 times the square root of 8 times x to the 9. Alright, so what we're going to do is make one big fraction. And we're also applying our properties of exponents. Okay, so 72 divided by 8 is 9. Okay, and then x to the third over x to the 9. So when we're dividing exponents, we're actually subtracting them. So x cubed minus x to the 9 equals x to the negative 6. And with negative exponents, we can actually just turn them into a fraction and put the variable and the exponent on the bottom. So that's going to be on the bottom here. And we have x to the 6. And on the top, we just have 9. Okay, because the x went to the bottom. Alright, so now we need to simplify this. And our next step is to make each of these back into its own little radical. So square root of 9, 9 is a perfect square, so we know that's going to be 3. And then the square root of x to the 6, remember when we are taking the square root, we can do the exponent over the index. If we don't see an index, it's automatically 2. So 6 divided by 2 reduces to 3. So we can take x cubed outside of the radical. So our simplified answer would be this. Then we have the 2 thirds in the front. So we have 2 over 3 times 3 over x cubed. So our final answer is going to be 6 over 3x cubed. And that's our answer for B. Okay? Or if you want, you can even simplify it further to be 2 over x cubed, because 6 over 3 can reduce to 2 over 1. Okay? So I would give credit for either of these answers. Let's simplify C. Alright, so now we're simplifying C. We have 5 times the square root of 18x times negative 4 square root of 32x. So we know that we need to first simplify the radicals. Okay? So we take a perfect square out of 18. Yes. 9 times 2. Okay? 9 is a perfect square. Remember, when we break out of jail, only one makes it out. So that means outside we're left with 5 times 3, because when we bring something outside, we have to combine it with the number already outside of the radical. So we're going to multiply these, and we're left with the square root of x underneath. This x can't come out because it doesn't have an exponent, so we can't simplify. Okay, so that means we have 15 times the square root of x times, now we need to simplify this one, and I'm going to use a different color so you can tell. Okay, so negative 4 times the square root of 32x. Alright, so 32 also has a perfect square. 16 times 2. Okay, and the perfect square there is 16. The square root of 16 is 4. So that means on the outside we're going to have negative 4 times 4. And underneath we're going to be left with a 2x. Cross that out because that came out of the parentheses. Okay, so now we are left with negative 16 times the square root of 2x. Now, because of our property of multiplying radicals, we know that we first need to multiply the numbers outside of the radical, and then we need to multiply the numbers underneath the radical. And to multiply the numbers underneath the radical, we have to have like radicals. So, sorry, I forgot this was going to be 2x. Forgot to bring that down. That should have been the 2x. Alright, so now we have like radicals. So we have 15 times negative 16. Alright. That's going to be a negative number. And of course, you can use your calculator to check my work. So negative 240. Okay, negative 240 times the square root of 2x. And the radical just stays the same, so we're really only multiplying what's on the outside. Alright, now for number 9. Okay, we have to simplify first before we perform the operations. So it says simplify, but we need to simplify each part. So 27 simplifies the square root of 27. We need the factors of 27. One of them is going to be a perfect square. So we can either find the prime factorization, which would be 3 times 3 times 3, or you could say 9 times 3. Okay? We know if we have the prime factorization, whatever the index is, which is 2 because we don't see one. So with the square root, our index is 2, but that means we need a group of 2 to take it outside of the radical. Okay? So remember, when we break out of jail, only one makes it out. Okay? So we can cross these out because they're now outside of the radical. Whatever doesn't come out stays underneath the radical. So now we have 3 times the square root of 3 plus 3 times the square root of 3 minus, and then we're going to have to simplify this one. Okay, so 12, our factors are going to be 4 and 3. So remember, this negative stays outside of the radical. So just leave the minus sign there, and don't forget to bring it down. Okay, so I'm going to change colors so you can follow what I'm doing. So 4 is a perfect square, 2 times 2. Okay, we break out of jail, only one makes it out. So we have 2, and underneath we're left with 3. Okay, so now we have like radicals. So all we need to do is perform the operation. So 3 times the square root of 3 plus 3 times the square root of 3 minus 2 times the square root of 3. All we're doing here is just adding the coefficients, so the number in front of the radical. And the radicand is going to stay the same. So 3 plus 3 is 6, minus 2 is 4. So our answer is going to be 4 times the square root of 3. That's your answer for A. Alright, now we're going to do B, so we still need to simplify. Now we have variables, but we still use the same rules that apply for simplifying any other radicals. Okay, so 27, we can find the prime factorization, 3 times 3 times 3. We already did that with the previous problem, so that was an easy one for us. Okay, we have 3 times 3, that's going to come outside of the radical because we need a group of 3. So now we need 3 times 3x. So I'm bringing this 3x down, because it was already in the front, and then I brought 1 3 out from underneath the radical. Whatever does not come out of the radical stays underneath. So plus 6 times 3x cubed. So we need to make sure that we have like radicals, or else we can't simplify it anymore. So 3x cubed, we can actually take out, we can't take out 3, but we can take out the x cubed. So that means we'll have x, 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 and we need a group of 2. Only 1 makes it out, so we're left with 6x. That's what goes on the outside. Radical, 3x underneath. Okay, we got rid of this. We're only left with 1 underneath. So we're about to bring this x down here. So now we have like radicals. So 3 times 3x is 9x times the square root of 3x plus 6x times the square root of 3x. Okay, and we're just going to add the coefficients or the terms in the front. So 9x plus 6x equals 15x. So our answer is 15x times the square root of 3x. And that is your simplified answer. Remember, we can't put this in the calculator because we don't have a value for x. So remember the rules for multiplying radicals in your notebook. This is just like multiplying binomials, which we did with factoring and with quadratics. For multiplying radicals, we're still going to multiply everything by every other term. So I'm going to show you guys with the box method because I think it's the easiest to visualize. Okay, so each term is going to go in its own space. Alright, so we're going to multiply each term. So the top parentheses, each term is above its own box. And the second set of parentheses, the second binomial, okay, is on this side. Okay, so the square root of x times 2 times the square root of x. We multiply the numbers outside of the radical, so we only have the 2, so that just stays. And then we multiply what's underneath the radical. So that would be x squared. Okay? And we'll simplify that later. So now square root of x times 3, we just have 3 times the square root of x. Okay? Negative 7 times 2 times the square root of x, we have negative 14 times the square root of x. So if there's not a term outside, then we can't combine anything outside. So if we have a coefficient here and not here, then we would just multiply the numbers in the front times whatever else is there. Okay, so negative 7 times 3 is negative 21. Make sure you're paying attention to your signs. Okay, so that means that we have 2 times the square root of x squared. We know that the square root of x squared is x, so I'm just going to put x. 2x, and then we have plus 3 times the square root of x minus 14 times the square root of x minus 21. So we can combine like terms here, and 3 times the square root of x minus 14 times the square root of x, because we have like radicands, the numbers underneath the radical symbol, that means that we can just add or subtract the coefficients. So 3 minus 14, we get negative 9, okay, times the square root of x. 2x minus 9 times the square root of x minus 21. and that would be our answer. Okay, so that would be our answer for 10A. For 10B, so for B, I'm going to use FOIL or rainbow math for multiplying binomials. Okay, so we have 5 times 5 is just 25. We do each term in a different color. Okay, 5 times 3 times the square root of 2. So plus, multiply the numbers outside and the numbers underneath the radical. Okay? And then inside times inside. So negative 3 times the square root of 2 times 5 is negative 15 square root of 2. So if you notice, this is a special problem. And then negative 3 square root of 2 times positive 3 square root of 2. So this is a special kind of problem, and it's called the difference of squares. So negative 9 times the square root of 4, which since 4 is a perfect square, we know that that's 2 times 2. And when we break out 2, only one makes it out. Negative 9 times 2 is negative 18. So these two terms cancel out. And here we have negative 18. So our answer is actually just going to be 25 minus 18, and that equals 7. So the answer to this super long problem, this problem, is just 7.